Hi. So in this video, we're just continuing the naming and the writing, going back between formulas and names and formulas, putting pretty much everything together with the polyatomic ions and the transition metals and the Roman numerals. So this first set of four is sort of the first step. I've already written the charge of the ions for you, so you don't need to look at a periodic table to figure out the charge of the ions. What you're really doing is figuring out how many of each ion you need in order to make a neutral compound. And a real quick way to do that is to crisscross the charges and take the charge of one, and that becomes the subscript on the other. The time that you actually don't need to do that is what we see in this very first one. So this very first one is a little bit different. And the reason why we've seen this before is because they both have the same charge. So how many barium would you need to match up with one this now would be called sulfide, right? Now that we know that the negative ions need to end in ide. So how many barium ions would you need to match up with one sulfide ion to make a neutral compound? And since barium is 2+ and sulfide is 2-, you just need one of each. So the formula for barium sulfide is just BAS. And this, we need to do the formulas and the names. So this would be barium. We just name the positive ion, and then sulfur becomes sulfide. Right? Here we crisscross. This is a good one where we crisscross the charges because we're going to need, now you can see 2 lithium, right? If I have 2 lithium for every 1 oxide, I will have the same number of positive and negative charges. So that would be Li2O, right? This 2 becomes the subscript there. This 1 becomes the subscript there, but we never need to write the 1 in. And then we just name the first guy, lithium, and then oxide, right? This is calcium and nitrogen. The 2 becomes the subscript down here. The 3 becomes the subscript down there. So this is Ca3N2, and we just name the first guy calcium, and then nitrogen becomes nitride. And then this guy comes down here, and this guy comes down here. So copper and iodine would be Cu(I)2, right? Because copper is 2+, so I'm going to need 2 iodide 1- in order to make a neutral compound. Now when we get the name, we just name the first guy, copper, and then notice I'm going to leave some space, iodide. I need to recognize here, and this is something that is really important, that first element, the metal, is a transition metal, which means I'm going to need to put the charge of the copper in Roman numerals in the middle. So the name for that compound is copper 2 iodide, because there is another compound, right? Cui could be another compound between copper and iodine. That would be copper 1 iodide. So we need to make sure that if we mean this guy, we need to use that Roman numeral 2. And why didn't I use the Roman numeral in the first 3 was because barium, lithium, and calcium are not transition metals. They only ever form one ion. So this is sort of going the opposite way. So looking at the names and then figuring out the formulas. So the first thing that we do here is we write the charges of the ions. And this is where you may want to have a periodic table handy so that you can look up the elements, knowing that this first group was 1+, then 2+, then 3+, then we skip, then 3-, 2-, 1-, and then we skip. So let's take a look at the first one, sodium iodide. Sodium is an alkali metal. It's in the very first group. It has a +1 charge. Iodine is a halogen. It's in group number 17. It has a -1 charge. And because it's +1 and -1, all I need is 1 of each. So that's the formula for sodium iodide. Tin 2 chloride. Tin, we need to remember, is one of those elements that its name is not, it doesn't really match up with its symbol. Your periodic table has names and symbols on them. So if you look up tin and you think, oh, I'll look under Ti, look at the name. It says that Ti is titanium. So tin is actually Sn, and it tells me the charge because just based on its location on the periodic table, I really can't tell the charge because it could be a number. It's one of those either transition metal or, underneath the metalloids metals. But the Roman numeral there tells me that it's tin 2+. Chloride is a halogen, it is 1-. Crisscross the charges, SnCl2 is tin 2 chloride. Potassium sulfide. Potassium is an alkali metal, +1 charge. Sulfide is underneath oxygen, it has a 2- charge. So K2S. Calcium iodide. Calcium has a 2+ charge. Iodine, another halogen, has a 1- charge. Crisscross the charges, Cai2. Okay? This is one of the most important skills of this chapter is being able to look at the name of a compound and writing its formula. So we now need to incorporate the polyatomic ions into this naming scheme. And it's not, there's one little trick to it. It's basically the exact same. You name the cation, you name the anion, and if the anion is a polyatomic ion, we just give the name of that polyatomic ion. But the formulas are going to look a little different sometimes. If you look at these bottom three, you see that they have parentheses, and we have not used parentheses before around chemical symbols. When do you use parentheses? We use the parentheses to separate polyatomic ions in a chemical formula. So you use them around the polyatomic ions, but not all the time. Only if you need to put a subscript on that polyatomic ion that is greater than 1. So you have to ask yourself, how many of that polyatomic ion do I need? And if it's just 1, no parentheses. If it's more than 1, you will need a parenthesis. So for example, potassium nitrate, right? Potassium is a +1 ion. Nitrate, you need to have that sheet or look back in your notes. Potassium nitrate is a 1- ion. Because I only need one of each, when I crisscross, no parentheses. But barium, an alkaline earth metal, is 2+. Hydroxide is 1-. So when I crisscross the charges, I'm going to need to put a 2 on hydroxide, which is a polyatomic ion. So I need to put parentheses. Because if I just wrote this is something completely different. This is 1 barium, 1 oxygen, and 2 hydrogen. And that's not what barium hydroxide is. Hydroxide is always OH-. It's never anything different than OH-. So I always need to have the OHs together. Right? I'm saying I need 2 OHs because if barium is 2+, I need 2 OH- to make a neutral compound. Ammonium phosphate. Ammonium is a +1 polyatomic ion. Phosphate is a 3- polyatomic ion. When I crisscross the charges, this 3 is going to come down here. 1, and so that's why we have to do NH4 and then in parentheses 3, PO4. Because what I'm saying is I need 3 ammonium, and ammonium is NH4. So I can never change this number. What a lot of students will do, and this is wrong, is they'll write NH3, PO4, but that's something completely different. NH3 is a compound called ammonia, completely different than ammonium. And this next one I put down here on purpose, Cobalt 3 carbonate. Cobalt 3, I'm telling you it has a charge of 3+. Carbonate is CO subscript 3 with a charge of 2-. This is a little bit tricky here. So we need to put subscripts down on actually both of these. And so it would be CO2 parentheses CO3, 3. And the reason I use cobalt and carbonate is because I want you to take a look at your penmanship. Your O's need to be significantly different sizes. When you are writing cobalt, that is a capital C and a lowercase o. I know that different people have different handwriting styles, but if you're writing cobalt like that, that's not cobalt, that's carbon monoxide. It's something different. So please just really make sure that you are significantly making it a lowercase o so that I can tell that you mean cobalt. I will take points off on the test for that. So the next 2 slides and the rest of your piece of paper is just really more practice of these. Okay, so I'll do the first couple and then I'll leave the rest for you to try. And then when we go over these notes in class, I'll look to see that you did complete these and we'll check our answers. So sodium nitrate, the first thing we do is we figure out what are the charge on the ions, and I will usually write them out. Then crisscross the charges. I actually only need one of each here. So NaNO3, no parentheses because I only needed one nitrate. Sodium carbonate, Na plus, carbonate is CO3 2 minus. Crisscross the charges. Na2, CO3. Make sure that O is a capital O. Magnesium nitrate, Mg 2 plus, NO3 1 minus. Crisscross the charges. Mg, now I'm going to need to put a 2 on the nitrate, so parentheses, NO3 2. Think if you didn't put those parentheses there, it would be NO3 2. It would look like 32. That's not what that means at all. Calcium hydroxide, Ca2 plus, OH minus. I'm going to need to crisscross the charges, bring that 2 down. Ca parentheses OH2. Some people like to simplify, they don't understand the rule. And so they sort of falsely memorize that, oh, if there's already a subscript, I need to add parentheses before I put another subscript down. That doesn't work all the time. That didn't work here, right? There's no subscript on the hydrogen, so then how would you know you need to use parentheses? So you really do need to memorize that rule. So there's 4 more for you to try below. The next group is just going the opposite way, right? So now this is easier most of the time because all you need to do is name the ions. Na is sodium, and SO4 is sulfate. Magnesium, carbonate. And that's why it's important that you learn these polyatomic ions, because if you are spending 10 minutes looking on the periodic table for the name of CO3, it's not there, okay? So that's why it's really important that we know these. Aln is aluminum, and this is plain N. That's nitride. So IDE is the ending on, if it's the element, just the element, no oxygen. When it is the element with oxygen, that's nitrate or nitrite. And this next one is the trickier one because this is a transition metal, which means when I give its name, I'm going to need to write what is the charge on it. It's iron something nitrate, but iron what? And this is where you have to use logic or just go backwards, uncrisscross the charge. It's not always sometimes so easy, but if you know nitrate is a 1 minus ion and you needed 2 of them, that means your total negative charge was 2 negative. So your total positive charge must have been 2 plus. So this would be iron 2 nitrate. So when you go and do the rest of these, remember that there's a few things that might happen. This is a transition metal. This is a transition metal. So the Roman numeral is going to tell you the charge. Think about, do I need parentheses or do I not need parentheses? In these, for chromium phosphate, you're going to have to figure out the charge on the chromium.